It would be really nice if you could show how to solve 2 to the x is equal to x plus 32 the proper way, because YouTube is full of the same wrong method, which results 256 only. But we all know this equation has 3 solutions by simply checking the graphs. Alright, in fact I have a similar video, 2 to the x is equal to x to the second power. If I've seen that video, then this video will just be a review. But here we go. First, we'll just take the natural log both sides so that we can bring the exponents to the front. However, here we have x to an even power. When we bring the even power to the front, we need the absolute value around the x. So we actually have to consider 2 cases, when x is positive versus when x is negative. That's how we take care of the absolute value situation. So case 1, when x is positive, well, the left hand side is just x ln 2, and the right hand side we have 32 ln, the absolute value wouldn't matter, just keep it as x, like that. The second case when x is negative is that you will have to put ln of negative x, but we'll do that later. Now we'll just put all the x's on one side and all the numbers on the other. So I will bring the 32 here, so that's ln 2 over 32, and that's equal to x here, that will be x to the negative 1, and then times ln x. Now what do we do? Here we have x to a power times the natural log of x. Our best bet is to use the fish function, aka the Lambert W function, or the other way around. The Lambert W function, aka the fish function. And let me remind you guys this right here. The key is, if today we have a fish times the number e, which is approximately 2.718. It's not that I changed it, I forgot to change it back. But anyways, e to the same fish power. Once you have the expression in this form and take the Lambert W function, you will get the fish back. And I have done many examples and an introduction video on the Lambert W function. You guys can go ahead and check them out. The links will be in the description. Now, how do we put this into this form? Here, when we have x to a power, we can write it as e to the ln of this thing right here. Because e and ln cancel, this is the same as that. And of course, here we have a power. We can bring the power to the front. So let me just erase that and then put a negative right here. And then we still have this ln x like this. And the left hand side is, of course, still ln 2 over 32. But this is not the same as that because we have the negative. Don't worry. Look at this equation and just multiply both sides by a negative. Now, this matches with that. So this is the fish. Then we can just proceed by taking the Lambert W function both sides. On the right hand side, we'll just get the fish back. So we'll just get negative ln of x. We'll just get that back. And then on the right hand side, I will put down this right here, which is the Lambert W function of negative ln 2 over 32. Now, we'll just need to get x by itself. Check this out. X will be what? I will divide the negative, both sides will multiply both sides by negative 1. So we will get negative w of negative ln 2 over 32. And then to get rid of the natural log, we exponentiate both sides. So e, right, e to the power. So this right here is e to the negative Lambert W function of this number. And now you might be wondering, in fact, we have 2 positive real solutions for this equation, but this is only one expression. How can we produce like 2 answers from here? It depends on what branch of the Lambert W function that you use. So this right here actually has a subscript. So this is the time that you will have to utilize Wolfram Alpha. The Lambert W function is the same as the product log. if you enter 0 right here, you get the first answer. And I'll tell you, if you make n equals 0, you will get x is approximately 1.022. But what happened to the 256? Do you put n equals 1? No, because if you do that, you actually get the complex solutions for this equation. And of course, feel free to produce as many complex solutions as you would like. If you want the other real solution, you put n equals -1, and that's how you enter it on Wolfram Alpha. And this is how we get x is equal to 256. So we have the two answers now. Well, let's go ahead and do the second case for the negative solution. So when x is negative, the left-hand side is still going to be x ln2. The right-hand side is 32 ln absolute value of x. You change that to -x, so that this negative times -x will still have positive result inside of the natural log. Then we proceed just like earlier, divide this here, so we have ln2 over 32, and that's equal to x to the negative first power here, and then ln of -x. Now we have to be super careful here, because earlier we just put x to the -1 power as e to the ln of x to the -1. But this time we have ln of -x. Yes, I can put a -1 to the front, but this thing here is not the same as that. So what do we do? Don't worry. Have a look here. I'm just going to multiply both sides by negative. And you also have to be careful right here a little bit, because if you just put negative right here like this, the power is not, you cannot just bring that to the front. No. However, this is just -1, right? So it's actually okay, because this is the same as saying negative x to a -1. Since -1 to a -1 is still -1, so we are still good. Yeah, so this thing here is really negative x to the -1. Then we can legitimately bring the -1 to the front. And then we still have the left-hand side, which is the negative ln2 over 32. But now, you see, here we have this negative. This thing right here needs a negative, right? So I'll just have to bring this negative to here. So we'll bring this back. So it might be a little bit confusing with a negative. Just be careful with it. That's all. Now this time we have negative ln of -x. Yeah. And then we can still take the Lambert W function. We get this time, the fish is this, which is negative ln of -x. And that is equal to that Lambert W function of positive ln2 over 32. Okay, x is equal to, you first divide the negative here, so you have negative w of ln2 over 32, and then get rid of the e, you have the, get rid of the ln, you have the e, lastly you get rid of this negative, you have the negative here. Yeah. And now you can just use the default branch, which is when n is equal to 0, and you can get x is approximately negative 0.979. So these are the answers that we have. These are the only 3 solutions that are real, and if you go to different branches, you can get complex solutions. That's it.